Here we are. How you doing, everybody? Soils. Soils are important. We did weathering, and now we're going to do soils. So, first thing, new vocabulary word right out of the box, regolith. And first time you hear regolith, I personally, every time I hear regolith, I go back and I look at that footprint right there, and I see this thing right here. Because when I hear regolith, I think of the moon. So regolith is the layer of rock and mineral fragments covering all of the Earth and the moon and any other planet, right? It's rock and mineral fragment. How do you go from regolith to soil? Regolith is just broken rock, minerals, the stuff that's in there, just loose, compacted. The stuff on the moon is very dusty, very sharp. It would not be, it's very, very, very fine powder. Now, there's no liquid on there to get it to clump together, and there's no weathering. There's no erosion on there. So the edges will be, if you tried to walk on it barefoot, forget all the no air stuff, it would be very sharp. Nothing has weathered that down. It would not be a pleasant, even if it is soft and powdery, it's going to be more like an abrasive powder than a baby powder or talc powder. So regolith, that's the rock and mineral layers. But soil is the regolith that supports plant growth. So it's rock and mineral layers that support plant growth. And that's the difference. So we're going to look at three big categories of soil: composition, texture, structure. Composition is pretty easy. What's the stuff made of? This is fairly standard chart. This is good soil. All right. Minerals, particles, 45%. 5% organic matter, whether that's the roots, the organisms, the humus, or not. Air and water, a quarter each. About equal parts air and water, because they come in the empty spots in between these other things, and they are able to move through the soils. Check another spot here. Hey, look. Still 45% mineral, 5% organic water, give or take 50%. You want the other half to be evenly mixed air and water. You don't want it to be compacted. So the first thing that happens is you compact it. Well, you think you get rid of the air, but you also get rid of the water permeable space. So it runs differently. All right. So the mineral matter, we need to talk about the mineral matter. That's later. We need to talk about the mineral matter. What is it? It's broken down rock, right? The organic matter, the humus, it's not hummus is what you eat. Humus is decayed remains of organisms, whether that's plant or animal. There's bacteria. It's living or formerly living things. That's what humus is. Air and water, those are the four components. And this is a good mixture for what the composition of soil is. This varies a lot, right? The organic matter varies a whole lot. That's all. Now, okay, how do you evaluate the soil? Sandy. So this is texture. And the USDA years ago did a great job, and they kind of organized what's going on. We've got sand, loam, clay. So sandy, loamy, and clay. It's not clay-y, clay-like. I'm from Sikeston originally. Soil down there, lots and lots of sand because it's flattened out. From there to the Gulf, it's just flat. very sandy soil by comparison. This is what everybody wants right here. This is not what everybody can have. You want the good stuff, right? It depends on what you want to grow. Some things need more clay. Some things need looser sand, let the better, different drainage. All right. This is about texture, what it's made of. So, online, the USDA, U.S. Department of Agriculture, soil calculator, percent sand, percent clay, and silt. They call it silt because loam is in here. So it's clay, sand, and silt. I guess really I should say clay, sand, silt. If you get a good mixture of all three, then you get the good loamy stuff. Okay. We're going to take a minute because I want you to be able to read this chart. I want you to understand this chart. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And a third time, 0 to 100 going this way. We've got 3 0 to 100 axes chasing each other, and you've got to figure out what. So this is not an XY graph. There are 3 axes going on here. So if I pick a spot right, let's just go right here. How in the world do I figure out, you know what, I lied. We're going to pick here so that we can come back and we know we're hitting the same spot again. If I find some soil and I dig it up and I do the calculations and it shows me magically this right here, we're going to take the horizontal line. Horizontal line. Take any line. Look out here. That is 65% clay. And then if I look on this line, right, I want to know that that is only 15% silt. And then this line, if I go down this way, it's 20% sand. Right there. Take each line to the left. That's the way to think of it. So take the horizontal line. Do I take the horizontal line over here or over here? Do I take this line up here or up there? Well, if you take it to the left, you got to tilt your head. Take it to the left, and you said that's up and to the right. Well, I guess you could spin the triangle so that there's always a flat bottom. When there's always a flat bottom, take the line that's horizontal to the left. So if you rotate your screen right now, and so that this clay is on bottom and this point is up, this side would be the left. So the lines going this way are going to go over to here and tell you how much silt there is. And then if you rotate it again so that the silt's on bottom and the sand is over, you take and you go left this way along these lines. Use the one that's clay right now. Clay's on top. Those are horizontal lines. Boom, 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 boom. And if they're horizontal lines, then the axis is on the left. So whichever way this line's going, I want to go out to that graph. No, I don't want to trace this down to this graph. This is the silt lines go this way, and then the sand lines go this way. This works better if I had a colored one. There we go. So the percent clay goes up as you go this way. The more silt you go down this way, and the sand. So this is beach sand and nothing else. This is modeling clay or art clay, and this is silt. These are all mixtures. This is going to be 30, 30, 30 right here in the middle. 33, 33, 33. Somewhere right there in the middle. And these are the names for each of the different categories of what's going on. And you could put in your percentages. Let's see. Percent clay, sand, 30. And the percent clay, 25. It's a type, which means 45% silt is left. And it puts a dot right there. Ooh, and I can change the color on the graph. So now I can add a blue one that is 60 and 30. And that put a blue one on there. And then I didn't, because I didn't reset it, it left the other one. That's why. And it tells me it's sandy clay loam, right? And when it says percent sand, if I want to be more detailed than 60, I could break it down into the thing. Because when you pull up sand, you've got all sorts of mixtures, right? This is all texture. All right. If not that far from here in Sikeston, it's very sandy soil. When we lived out in South Carolina, we lived upstate, not off the coast. It was very, very clay, heavy clay, and agriculture was entirely different than what it is here. And agriculture here in Jackson is entirely different than it is even just 40 miles, 35 miles south in Sikeston. Because there are no cattle ranches. There's no cattle in Sikeston. It's all crop farming. Here, there's a whole bunch of cattle and not very little. There's much less crop. And in South Carolina, it's entirely different crop. Weird. And it's all down to what the land below your feet will grow. This is important. All right, that's a good spot. We're going to leave that up there. We're going to get rid of that one. All right. So now, structure. One more thing. So structure. So if there is soil, we're worried about composition, texture, and structure. Structure is how the particles clump and form. Wait, I know I've got a thing. There we go. Soil structure. I knew I had a slide, something visual for you guys to see. How easy does the water get from the top layer to the bottom layer? Or does it get to the bottom layer? Right? Structure is how the things are grouped and assembled. That's it. Now, soil formation. How do we make soils? Okay, all these things we're about to talk about interact. This is the Global Land Data Assimilation System. It's a satellite. Here's what it does for NASA. Boom. Here are all the soils across all the continents. There's all the major soil types. It's much more detailed like this. This is a global picture, right? You can zoom in, and even across one farm, you'll have different soil types from one end to the other over just those few acres. So this is broad pictures. But if sand is down here in the ones and loamy sand, and you move through, you come back around to bedrock, and you got some other out here, all of this. Sorry about that. All right. Just saying that you can get this global picture of this, or you can get a local picture of this. All right. So this is by clay, this is by sand, this is by silt percentages, soil properties, the soil color across the entire globe. That's weird. I mean, Earth looks blue and green from a map. Well, you can do amazing things with satellites and get the color of the dirt below your feet. That's pretty wild. They use CLORPed. Here's what we're going to talk about. How are soils formed? I don't like the CLORPed acronym, but we are going to talk about parent material, time, climate, organisms, and slope. They don't say organisms. They say organisms. This other page says biological factors instead of organisms. And they don't say slope. They say relief. Relief is the angle of the land, if you will. So you hear relief when you're talking about like mountains. Mountains was the steepness of a mountain, not like a river valley's relief. You wouldn't necessarily use that there. But how are soils formed? Time. What is it made of? The parent material, right? Most important of all of these things, climate. Climate trumps all of them. It beats all of it. They all interact very, very complex ways. Okay. Time takes a long time to make soil, to make dirt. You've got a rock. How do you turn a rock into soil? Time. That's how. You weather it down, you break it apart, you mix it up, and eventually you get some type of soil. Whether it's good soil or bad soil, it's soil. The most important one is climate. All right. Let's back to texture. All right. The most important one is the climate. You can take two different parent materials and put them in the same climate, and in the end get the same soil type out. So I take two different rocks, like different types of rocks, but if I put them in the same climate, I can get the same soil out. I could do the reverse too. If I take the same types of rocks and I put them in two different spots, one dry, one wet, one hot, one cold, whatever, I can get two different soils out on the far end. Climate matters the most. Climate matters the most. After that, I would say the rest interact so much, it's hard to put one over the other. The parent material is the source of the minerals, all right? Whether that's bedrock or unconsolidated deposits. So the unconsolidated deposits, unconsolidated, those are things that are laying over the bedrock, but they're not compacted down. They were almost washed in themselves, and they're going to start to build up soil. Soil that forms on bedrock is residual soil, and soil that forms on the unconsolidated deposits is soil that transported in from somewhere else. Sorry about that, bumped the screen. Soil that transported in from somewhere else. So it's flowing down the river, right? It's washing over in a storm. That soil is moved in. So it's usually from a different parent material. Okay. The parent material determines the weight of weathering, the rate of weathering, how fast it weathers. It determines the fertility. It determines all those stuff. The longer soil forms, the thicker it becomes. That's the time. The climate, we said, is the most important. Organisms or the biologic factors. Plants are the main source of organic matter in soil. Animals, microbes, way down the line. Plants are where all this biological material comes from. Slope can vary a lot, even in a short distance, right? Things high up on the mountain, it's going to erode down. Halfway down the mountain, the bottom, you're going to have the deposits of those things from above. You're going to have more water at the bottom. You're going to have better soil at the bottom of the slope or even in the flat. Kind of depends. If the bottom, the true bottom, is so flat that it gets wet and holds water, it's not the best soil. It might be just up where it's got good water but not soaking and sloppy. We're going to go back. We've got a couple activities. I may assign some today or may assign some Wednesday. We've got one more issue. What have we got? We've got profile and activity. We're going to profile soils, okay? You're going to profile the soil. So put your detective hat on. We're going to go out there and see what this soil's made of, right? And we're going to look at all that, and then we're going to have spring break. So enjoy. Have a good day.